All right, so 4.10 vertical line test domain range. All right, so let's start looking at this. All right, so when we look at it, what we're looking for is what does it function mean? All right, function is just a one-to-one relationship. All right, so for just a lack of a better way of saying it, think about a function as a relationship like boyfriend girlfriend, boyfriend boyfriend, girlfriend girlfriend, whatever. All right, it's just one person and another person. So a one-to-one relationship is just one number and another number. And then they're saying for every input there has to be a unique output. And the way I like to think about this is when I think about it, I always just like to say there can only be one x value in the set of numbers. Okay? Because remember, input is x values, output are the y values. All right, so for every input, there is a unique output. So there can only be one x value in a set of numbers. I just try to simplify it. I try to make everything as easy as possible. You guys already know that. All right. So let's look at this first one. Determine if each of the following represents a function. Explain your answers. Well, right away, what am I noticing? I'm noticing two x values. And with the x values, the y's are different. All right. So is this thing a function? No, not a function. All right, not a function because x equals -4 has two different y values. All right. Now let's look at this one right here. All right. Is that one a function? Well, the very first thing I'm going to look at is I'm looking at all those y values. Excuse me. Oh my God. I'm looking at all the x values. Well, I notice that they're all different. That's all that matters. Do I care that I have two y values that are the same? I don't care. All right. All I worry about are the x values. Are they all different? Yes. Since they're all different, this is a function. All right. So, yes, it's a function because there are no x values repeating. All right. So, yes, when they tell you to explain, you actually have to write this mess out. All right. You have to explain the yes and the no part. Yes, because, no, because. All right. Now, number two, use the graph to complete the table. So, what are they giving us? They're giving us a whole bunch of x values. All they want us to do is write in what are the y's. That's all they want us to do. Okay. So, x equals -2. Well, x is equal to -2. All right, there's x equals -2. Where does it cross? Where does it cross the graph? It crosses the graph right there. So what is y? Y is 0. -3. All right, -3 is right here. Where does that dotted line cross the graph? It crosses right there. Oh wait, no, it doesn't. And I have my glasses on. I guess I just made a big mess of it. All right, it crosses right there. So it crosses at -6. All right. What about 3? So I look at 3. There's 3 right here, right? So there's 3 right there. Where is it crossing? Let me stop making a big mess of everything. Where is it crossing? It's crossing at 0. What about 1? All right, 1 is right there. All right. Oh my goodness, what happened? All right, so 1 is about right there. It crosses at 3.5. If I'd have blew this up a little bit, it would have made it probably look a little bit better, but I was trying to fit everything on here. All right, and then -1. -1 is way up here. All right, there's -1 right there, and that crosses at 5. Does this graph represent a function? Yes. All right, yes, it's a function. Yes, it's a function. Explain. Because. All right, so why is this thing a function? Again, I'm looking for x values that are repeating. Do we have any x values that are repeating? Well, I can look here. There's no x values there repeating, but am I limited to just those x values in the table? No. I'm going to look at this graph, all right? I'm looking at this graph. Do I have any x values that are repeating here? No, they're all individual. They're all individual graphs. Excuse me, they're all individual x values, okay? So this is a function because there are no repeating x values. All right. So now, vertical line test. All right, a vertical line test, all that tells us is it a function or not? All right, so a vertical line test, think vertical line. So a vertical line that goes straight up and down. And what we want to do is we want to think about this vertical line where we can move it. All right, so we want to think about this vertical line being able to move this thing. All right, so think about sliding your ID left and right vertically. Does it ever cross the does it ever cross this graph? Would that vertical line ever cross that graph more than once? No. All right. So this is a function because it passes the vertical. I'm lazy, so I'm just going to put VLT. It passes the vertical line test. All right. Now, I know sometimes it's a little bit tough to figure out just seeing one. So let me show you here with this one. All right. So let's look at this graph here. So there's the graph. All right. Now they're showing me a vertical line right there. All right. So they're showing me that vertical line. Does that vertical line hit more than one point? Yes, it hits 2 points right there and right there. So is this thing a function? No, not a function because it fails the vertical line test. All right. Again, vertical line, it can only hit the graph one spot. All right. So like over here, I'm looking back at the left one. It only hit right there one time. If I were to draw another vertical line, all right, it's only hitting the graph one time. Nowhere will that vertical line ever hit that graph more than once. So the left one passes, which makes it a function. The right one fails because it hits more than one. It hits the graph more than once. All right, domain. Domain is all the input values. All right, all the input values or the x values. So here's your domain. Your domain is going to be from left to right. All right, domain is from left to right. So in this case, in this graph here, what's the domain? What x values can I use? Well, if you look, this graph is going up forever, right? It's going up forever. But at the same time, what do you notice? It's going left and right also. Yes? All right. So this graph is actually going to the left and to the right. It's getting fatter and fatter, left and right. All right. All right. Enough with the fat jokes, guys. All right. But seriously, this graph is getting bigger and bigger, left and right. It's getting fatter and fatter as this graph continues to go. As it continues to go up, this graph is getting fatter and fatter. It's getting wider and wider. Okay? So the domain here would be all real numbers. All right? And there's a symbol for it. Remember, people in math are lazy. So there's a symbol. It's a capital R. Let me at least make it look like a damn R. All right? It's a capital R with two sticks. Okay? So capital R with two sticks. That's the symbol for all real numbers. So it's all real numbers because we can use any x values. All right, I could pick any x values and it'll eventually be there because this graph is just getting wider and wider. It's going from to the left and to the right forever. All right, so x can be any positive or negative number. All right, so if I said, can x be positive 1,335? Yes. Maybe not here somewhere, but way the hell up here somewhere, where this graph keeps going forever and ever. It keeps going forever and ever that way. Maybe eventually it'll hit that number I just said that I forgot already. All right. Could it be eventually get to a negative 1 million? Absolutely. All right. It just because it's not going to go, it's not getting fat real quick, but it's gradually left and right. All right, left and right, I'm able to get those x values. Now the range. All right, here's the range here. It's vertical, up and down. All right, so the range is up and down. So in this case, the range is all real numbers greater than or equal to -4. All right, so let's look at this. So you see right here, let me see if I can zoom in on this, because this is, even with my glasses, is kind of small. I think I gotta do this first. View. I'm sorry, guys. Bear with me. All right, a little bit better. All right, a little bit better here. So the range, you see, this graph starts at -4, so it's gonna be all real numbers greater than or equal to -4. Because remember, greater than is that way. All right, because I'm looking at the y values now. So up and down. This graph, you notice there's nothing down here. There's nothing down here for this graph. It starts. It's what the hell? There we go. All right. It starts down here at -4. There's nothing lower than -4. So that's why this one is all real numbers greater than -4. Now, the way people in math would write this, because people in math are lazy, you would say y is greater than or equal to -4. So that's how you would say the range. And then up here to this, for this one, all right, all real numbers, again, they would just use that R value, all right, that symbol, all right. And so this one, it keeps going up forever and ever. It's never going to stop. So if I said, can y be 1 trillion, whatever, yes, it can be just a huge ungodly number. Okay. All right. Now, vertical line test. This vertical line test, to check to see if it represents a function. All right, so it was the same. It was the same test that we did. Where the hell it was? Right here. All right, so it's that same test. Now, all I want you to think about is, here I have a vertical line. Drag this vertical line across the graph. Does it ever cross the graph vertically more than one time? All right, no. I don't know why it jumps from spot to spot, guys. I have no idea. But think about dragging your ID across there vertically. Will it ever hit that vertical? I mean, will it ever hit that graph more than one time? No, since it's always going to hit one time, since it always hits one time, when it always hits one time, we're going to say this one is a function. All right. Now, what about, oh, come on. There we go. What about B? Again, I drag this line, all right, I drag in my vertical line across the graph. Does it ever hit more than one time? Nope. Oh, come on. I don't know why I'm having such issues right now. I apologize. All right. So this one is a function also. Now let's look at C. Let, let's check C. Is C a function? Well, if I grab this, well, you'll notice, damn it, it won't line up. Crap, I thought it would line up right on top. I was hoping. That's what I was hoping for, guys. All right. Well, anyway, let me draw my perfectly vertical line here. Perfectly straight line. All right. Hey, that wasn't half bad. Yeah, I can be proud of myself. Stop laughing at me. All right, I can be proud of myself here. All right, so you'll notice that vertical line. It hits that our original graph. It hits it everywhere. All right, it hits it everywhere. So this one is not a function. All right, not a function. Now let's look over here at this last graph. I start grabbing it. All right, as soon as I get right there, what happens? It hits it twice. Not a function. All right. So far, so good. All right. All right. So use the function f of x is equal to the square root of x minus 2 and its graph to determine the allowed inputs and the possible outputs of the function. All right. So what do I want you guys to think about? These inputs are the domain. All right. We just finished talking about that. Outputs would be the range. All right. So let's think about this. So for number 4, all right. So for number 4, the domain. All right. Remember the domain. Domain is going to go left and right. Is it going to be all real numbers? All right. So for this one, all real numbers? No, because do I have anything over here? Nothing. There's nothing over there. So this one actually has a starting spot. It has somewhere to start. So the domain or the allowed inputs, all right? The allowed inputs would be x is greater than or equal to 2 because you notice it's starting at 2. It starts right there at 2. And then what happens to this thing? It's just going to go forever in this direction, all right? So it's just going to keep going forever that way. Okay? So, oh damn it. So there's my possible, I can pick any x value that's greater than or equal to 2. So I can pick 2.000001 or I could pick x's a a billion, all right, whatever. Just being ridiculous here. All right, now my range. Remember the range. This would be the output, the possible outputs. All right, so in this case, now let me erase that mess. Range is going to be up and down. Well, you'll look, there's nothing down here. There's absolutely nothing underneath. So what is it right here? This is my starting point. All right, that's my starting point. That's 0. So y is going to be greater than or equal to 0. And just like we talked about in one of those other graphs, as this thing travels to the right, it's actually also going up. Not very quickly, but it's going up. All right. Doesn't matter that if it goes up quickly or not. It is going up. All right. So there's the possible inputs, the possible outputs. All right. So number 5, domain and range. Again, all right. Domain is what what x values can I pick? Well, you'll notice that it's starting here, it starts right there, and it ends right there. All right, because remember, domain goes left and right. It has a starting point, it has an ending point. Well, when you're doing this, when you see a graph that looks like this, what you're going to do is you're going to have x in the middle, and you're going to have those two inequalities. The smaller number goes there, which is -4. The bigger number goes on this side, which is +4. All right. So the way we would read this, we read from the center. We're going to say x is greater than or equal to -4 and is less than or equal to 4. All right. So I'll write it down for you. This is going to be a pain to write, but this is why people in math are lazy and they use symbols. X is greater than or equal to -4 and x is less than or equal to +4. All right. Now the range. All right, with the range, let me erase all this crap. Range. Now remember, range goes up and down. Is there a starting point? Yes, there's my starting point because there's nothing down there. There's nothing underneath the x-axis. So where am I starting? All right, so again, my smaller number. So I have y in the middle is greater than or equal to, less than or equal to. So what's my smaller number? Well, remember, the x-axis. The x-axis is, oh damn it. The x-axis is 0. Now, what's the biggest number? It only goes up to right there. There's nothing above it. There's nothing above it. So what's the biggest number? The biggest number is 4. I'm not writing this one out because I'm too damn lazy. All right, number 6. From the graph of this quadratic function, find the domain, range, identify the zeros, and locate the vertex. How does the vertex of the parabola help you determine the range? All right, so let's look at this. Zeros. Where are the zeros? Remember, zeros is where does it cross the x-axis? All right, so my zeros, since I don't know exactly, I'm going to say it's approximately equal to. Well, here's 1, there's 2, so I'm just going to say approximately 1.5. And x is approximately equal to, there's 4, there's 5, so let's just call it 4.5. All right, at least make it look like a 5. The vertex. All right, you guys remember where the vertex is? Vertex is either maximum or the minimum point. Well, in this case, since this opens down, the vertex is going to be the maximum point. So this point is going to be 3, 5. So 3 and 5. All right, domain. Domain. Remember, domain is this. Well, what x values can I pick? I can pick any x value because as this graph goes down, as this graph is going down, what's happening to the graph? It's getting wider and wider. All right, it's getting fatter and fatter. So the domain is all real numbers. Or remember the symbol, capital R with 2 sticks. Okay, now the range. Let me erase this. The range, up and down. Well, in this case, we have to know that range. Is there anything up here? There's nothing up there. So can I say it's bigger than bigger than that? Can I say it's bigger than this? No, that's my biggest point. All right, I mean my biggest. Sorry, that's my highest point. So the range is going to be y is, all y values are going to be less than that point right there. And what was that point? 3, 5. What was the y coordinate? The y coordinate was 5. So how does the parabola help us determine the range? Whatever the vertex is, in this case, y is less than or equal to 5. If the graph were opening up, then we would have said y is greater than or equal, greater than or equal to 5. All right, if it were opening up, if this thing opened up, we would have said greater than. But it, it's opening down, so y is less than or equal to, because all these y values, all those y values are lower than 5. So how does it help us? How does the vertex help us determine the range? It helps us because you'll notice that that 5 and that 5 are exactly the same. All right, that's where that 5 came from. All right, so hopefully this helped. Hopefully this isn't too tough. All right, if you have questions, please send us questions.